I'm Melissa Wilson from the University of Minnesota. I'm the Manure Management Specialist and an Assistant Professor in the Department of Soil, Water, and Climate. Today, I'd like to talk a little bit about some of the research that we're doing looking at nitrogen and phosphorus in manure. Let's get started with a history of manure availability factors. Our current guidelines were generated in the 1990s and were based on the total nitrogen and phosphorus content in manure as analyzed by a lab. One of the limitations is that though we have differences for species, the different handling systems, whether it's liquid or solid, we don't account for those. So for phosphorus, we assume about 80% of total phosphorus is available in the first year for any kind of manure type, regardless of where it's applied or how it's applied. But nitrogen is a lot more complicated. Nitrogen, it depends on species. So here you see we have beef, dairy, swine, and poultry. And it also depends on how it's incorporated, at least in the first year. The faster you get it mixed in with the soil, the more likely you are to preserve nitrogen. And you can see that reflected in our tables here. So injection is, for liquid manures, kind of your best case scenario for preserving your nitrogen because it really reduces ammonia losses. With broadcasting, once you have that available to the atmosphere for the volatilization to happen, that's a nitrogen loss. So the more quickly you can get it incorporated, the better off you are at preserving the nitrogen. So within 12 hours, again, is kind of your best case scenario for broadcasting. If it takes 12 hours up to 4 days, then there's less nitrogen that will be available. And then if it's over 4 days, or if you just do no-till, you'll still have nitrogen left because you have that organic portion of nitrogen that's not volatilizing. But you can assume that the ammonia portion is going to be lost. And then we have differences based on year. So the first year is where that ammonia influence really comes in. And the second year, you'll see it's the same regardless of how it's incorporated for each of the different species. And that's because that ammonia factor doesn't come into play. So we know that there's new technologies with manure handling, with manure application, and we know that it's been getting progressively wetter in Minnesota. So we wanted to reevaluate those nitrogen availability factors as well as the phosphorus availability factors to get a better understanding if we need to make tweaks to our guidelines. So we started research at 2 different locations. One was in Waseca, Minnesota at the Southern Research and Outreach Center. The other was in Lamberton, Minnesota at the Southwestern Research and Outreach Center. And then within each location, we have 2 different sites. The first one was started in 2018, and the second was started in 2019. What we did is we have 6 different types of manure. We have a liquid swine finishing manure, bedded beef pack, 2 types of dairy. The first is a regular raw dairy. The second is a liquid separated portion of dairy. We have a poultry litter, and we also have a turkey layer manure that's been composted. And what we wanted to do was apply these based on our current guidelines. So we aimed for getting 140 pounds of first year available N per acre. We applied those the first year, so 2018 at Site 1 or 2019 in Site 2, and then we did not apply manure or additional nitrogen and phosphorus fertilizers to those plots for the next 3 years. But simultaneously, we did have some fertilizer plots. We did some with a nitrogen rate curve, and we did some with a phosphorus rate curve to try to better understand what responses will look like to nitrogen and phosphorus at each site, and then to be able to compare our manure plots to our known quantities of fertilizer. So what we ended up with is 16 treatments at each site, and then each of those 16 treatments was replicated 4 times. And where are we today? Well, we just finished up harvest of our Site 1 plots. This is our last year for those sites, but we do still have 1 more year in our Site 2 plots. So we'll finish those up next year. So we don't quite have all of our data yet, but I do want to show you some of our preliminary findings. Just to give you some more details about our plots, we applied the full nitrogen rate of 140 pounds of nitrogen per acre. The corn in that year was following soybeans, so there was a credit there. And our nitrogen fertilizer rate plots included full phosphorus, full potassium, and a full sulfur rate. We just changed the nitrogen on those plots. So it went from 0 up to, I think it was 120% of that 140 pounds of nitrogen. For phosphorus, we did a similar thing, but we had full nitrogen and full potassium, but we changed the phosphorus, and that ranged from 0 up to 120 pounds of phosphorus per acre. Then in the second and third years, we did not apply any manure to our plots any longer. We did not apply nitrogen or phosphorus. We did apply full rates of potassium and sulfur though, because we wanted to make sure that those weren't limiting. We didn't want those influencing yield like we thought nitrogen and phosphorus might. On our nitrogen fertilizer curves, we again did the same thing from 0 up to 120% of the total nitrogen needs, although those plots had full P and K. Then for our phosphorus plot curves, we did the phosphorus rate and full nitrogen and potassium. Again, the idea was to be able to compare our manure plots to our fertilized plots, which had a known quantity of nutrients added. And we added the fertilizers every year because, again, we wanted to know where we had those known amounts of nutrients that were added each year. But for our manures, we wanted to see what the second and maybe even the third year credits was. So some details from our first year right after manure was applied, and this was applied in the spring, and we incorporated everything within 12 hours, trying to get the best bang for our buck for our nitrogen. One of the things that we noticed right away is that we were not getting the same bang for our buck from the different manure types. Here we can see a picture taken June 18th at the S Rock, where our turkey litter corn was much bigger and much more robust than our bedded beef pack. Here we have June 28th. And these are aerial photos looking down at the plots. And this is 2 reps, and I have each of the treatments labeled. So for instance, here's 0 fertilizer nitrogen control. The one I want you to compare that to is our bedded beef pack. So in this case, you can see the bedded beef pack was much lighter green than some of the other plots, and the rows weren't nearly as closed as the others either. So we saw early on issues with that bedded beef pack. Here's an aerial photograph of the same plots taken about a month later in 2018. And you can still see that our bedded beef pack plots are nitrogen deficient because they're lighter green, but they're maybe not quite as yellow as our 0 nitrogen fertilizer. So we're starting to see a little bit of nitrogen response, but it's still, compared to some of our other manures, for instance, not looking as good. So at the end of the season, here we have our Lamberton corn yields. This is the Southwestern Research and Outreach Center site. And I have all 16 plots here. I wanted to show you our manure sources. We have swine, beef, dairy, separated dairy, chicken layer, and turkey. And our corn yields range from 0 to 240 bushels per acre. This middle diagram shows you our nitrogen rate response curves, and remember they had full P and K added to them. And then we see our phosphorus rate response curve. Well, it's not much of a response curve because we didn't actually see much of a response in yields with phosphorus. This was a pretty interesting result in this case because the soil phosphorus tests were low for phosphorus, so we were expecting a response, but we did not see it in yield. One of the other things we're looking at is our phosphorus and nitrogen uptake of the corn. So when the corn reached maturity before harvest, we collected plant samples. So we got some of the stalk, some of the cob, and some of the grain from plants within the plots, and then sent them off for nutrient analyses. So this is our phosphorus uptake. And you can see it's pretty low, 0 to 40 pounds of phosphorus per acre. And it's not low necessarily for the crop, it's just lower. We'll see the numbers for nitrogen here in a bit. But here we have our manures, same order as before. And what's interesting is that our chicken layer and turkey tended to have more phosphorus uptake than the other manure types. And in fact, it tended to have more phosphorus uptake than our phosphorus rate curves too, which again was very interesting. But usually the chicken layer and turkey do tend to be pretty high in phosphorus content. Another interesting thing is that even though we did not see a yield response to phosphorus, we did see an uptake response where the 0 phosphorus rate plots did not take up as much phosphorus as the other plots. So again, it's kind of those hidden issues that we sometimes don't always know about because they don't seem to be reflected in yield. Here we have our nitrogen uptake You'll notice the patterns very closely mimic what we saw for yield, with the swine, chicken layer, and turkey having the higher yields than the beef, dairy, and separated dairy. What's interesting is the nitrogen response in the fertilizer plots. Here we have just a little over 40 pounds of nitrogen taken up at the 0 nitrogen rate control plots versus 140 taken up at our highest nitrogen rate. So it's almost 100 pounds of nitrogen difference between our high and low nitrogen fertilizer plots. Now, one of the things that we do is we wanted to compare our manure to our fertilizer plots because the fertilizer is a known quantity. And what we can do is we can generate a response curve. And that's what you see here, an equation that illustrates how much nitrogen might be taken up by a crop dependent on how much nitrogen you give it. And from there, since we know how much nitrogen was taken up by the crops where there was manure, say swine manure, we can take that line and follow it over or plug in the nitrogen uptake, which is y in this equation, and then solve for x. And then from there, you can see how much nitrogen would have been applied, or the nitrogen fertilizer equivalent value. So we can do that for each plot. And here are what we averaged. So we have our manure source here on the furthest left. The next column is nitrogen fertilizer equivalent value. That's calculated just the way I showed you in the last slide. And then because we also know how much nitrogen we applied with the manure, we measured the total nitrogen content of it, and we know pretty accurately how much we applied because we applied it by hand and measured and weighed it out pretty thoroughly. We can tell how much our percent nitrogen availability was. And then the last column shows you what we assumed the percent nitrogen availability was. So in pretty much every case, you can see that the percent nitrogen that was actually available does not match the assumed percent nitrogen available. And one of the things I want to remind you is that 2018 was a very wet year. So that may have had something to do with that. If the microbes aren't, going at full efficiency, they might not be converting the nitrogen from the organic form that's in manure into the plant available form. And manure is made up of both types, a little bit of plant available and a little bit of organic nitrogen. And the ratio depends on the species. So that was our Lamberton Site 1 in 2018. Here we have our Waseca corn yields. And a little bit of differences here. In this case, swine, chicken layer, and turkey did really well compared to our fertilized plots. Bedded beef pack still did not do well. And one of the interesting differences is that our two dairies performed a little bit differently. Our raw dairy did not have quite as high of yields as our separated dairy did. Here's our nitrogen uptake values. And again, they're pretty well reflected by yields. And again, we can generate a curve, a rate curve, and then from there calculate what our nitrogen fertilizer equivalent value was for each manure type. So here's our results for Waseca. You'll notice that in pretty much every case, our percent nitrogen available was higher than it was at Lamberton, with the exception of our bedded beef pack. The bedded beef pack was actually a little bit lower availability at the Waseca site. All of them were below what we expected, except for the chicken layer. In this case, it released more nitrogen than we were expecting at Waseca, but not at Lamberton. So again, some interesting results between the two different sites. Now we are looking to analyze the nitrogen and phosphorus uptake of the remaining corn years. We meant to do some of that late last spring, and then COVID hit and we've been slowed down in our lab analyses. But I wanted to show you corn yields just to give you an idea of what those look like in the second year after manure application. So if you remember, we applied nitrogen, our rate curves, we applied our nitrogen fertilizers to the fertilizer plots, but we did not add any more nutrients except for potassium and sulfur to the manure plots. And the yields are pretty low because we weren't expecting a full rate of nitrogen in the second year. But you can see that they're not necessarily lower than 0. So if we highlight the area between 0 nitrogen applied and 49 pounds applied, you can see that all of our manures fall within that range, with maybe the exception of swine. It's right on the border there. So we are seeing a second year credit from all of our manures, especially the chicken layer and the beef. The bedded beef pack was releasing a little more in that second year, probably because not much released the first year. Here's our second year corn yields from Waseca. And again, if we highlight that area between 0 and 49 pounds of nitrogen applied in fertilizer, again, you can see that we are getting a second year credit for most herb manures, except for, again, the swine. So that was one really interesting thing that we saw with our swine manure, is that it releases a lot of its nitrogen up front, but it was much more slow to release in that second year, or perhaps most of it just did release in the first year. So take-home messages. As I mentioned, it was very wet both of the years where we applied manure. I remember thinking when we were harvesting in 2018, like, okay, thank goodness this is done. 2019 can't be that bad. And then 2019 was worse. So because of this, we saw our first year yields with manure were lower than expected. And we think that's because some of that nitrogen just never was able to mineralize because it was so wet. Now, our second year yields were higher than our no nitrogen fertilizer controls, which is what we expected. We expect at least a second year credit, except for with that swine manure. Of course, the question is, where did the nitrogen and phosphorus go? Well, one, we still have to look at plant uptake to see if we can see any trends there. But we also have a lot of in-season soil samples to go through to try to better understand what the transformations of nitrogen and phosphorus look like throughout the growing seasons, and to see if it was transforming to the inorganic or plant available forms, or if it was sitting in that organic pool of nitrogen or phosphorus. Thanks for listening to my talk. If you have any questions, feel free to get in touch with me. My email is mlw, it's my initials, @umn.edu. Otherwise, you can follow me on Twitter @ManureProf, or our University of Minnesota extension account is UMN Manure. Thanks, and I look forward to hearing if you have any questions.